When you think about the world's biggest companies, what's their most valuable asset? It's not the buildings, not even the products, it's their data. So, how do you move massive amounts of that data, we're talking terabytes, even petabytes, from an old system to a new one? And how do you do it without, shutting down the entire business for a week? The tools that pull this off are the real unsung heroes of the tech world. And today, we're diving into the story of one of the most important ones out there, Oracle's data pump. So let's rewind a bit. Before the cloud made everything seem so easy and instantaneous, what did you do? Just picture it. You're a database admin back in the 90s. Your company's doing a massive system upgrade, and guess what? It's your job to move all the data. There's no fancy high-speed transfer to the cloud. Nope, you've got a command line, a whole lot of patience, and you've already kissed your weekend goodbye. For decades, that was just how it was done. And that brings us right to the start of our story. We're talking about the original tools that for a very long time were the one and only option for Oracle DBAs. Let me introduce you to export and import, or as anyone who's been around for a while knows them, expent and imp. These commands came out way back in the late 80s, and they were the absolute backbone of the Oracle universe. The whole process was pretty straightforward, really. You'd run expent to create what's called a dump file, a single file with all your data, your schemas, everything. Then you'd physically get that file over to the new database and run imp to load it all in. And for a long, long time, this simple, reliable method was all you needed. But of course, technology never stands still, right? And neither does the amount of data we create. As databases just exploded in size, going from megabytes to gigabytes and then to terabytes, the cracks in this classic approach started to get pretty obvious. What used to be simple and reliable was quickly turning into a massive bottleneck. Yeah, the problems were becoming impossible to ignore. First off, these jobs were just painfully slow. We're talking about something that could take an entire weekend to finish. That meant the whole system had to be offline, which businesses just couldn't afford anymore. And on top of that, it was an all-or-nothing kind of deal. You couldn't just move a piece of the puzzle. You had to move the whole box. It gave admins almost no control. Something had to change. And that change? It arrived in the early 2000s with Oracle 10G. And look, this wasn't just some minor update. Oracle went back to the drawing board and completely re-architected how data movement worked. The result was a brand new tool called Data Pump. And this table right here shows just how huge that leap was. The old XPAMP and IMP, they were single-threaded, meaning they could only do one thing at a time, nice and slow. Data Pump brought in parallel execution, using all the power of modern servers to work on multiple streams of data at once. And instead of that all-or-nothing job that you'd have to start from scratch if it failed, you now had fine-grained control and restartable jobs. It wasn't just an improvement, it was a total game changer. And this is what it meant in the real world. We're not talking about a 10 or 20% speed boost here. A migration that used to mean a DBA was stuck at the office all weekend, just staring at a progress bar, could now be kicked off and finished before they were even done with their morning coffee. For database administrators, this was absolutely revolutionary. So, how did it all work? Well, it came down to a few key innovations. We already talked about parallel execution. Then there was something called direct path access. Basically, instead of going through the slow, traditional SQL layer, Data Pump could write straight to the data files, orders of magnitude faster. The ability to pause and restart a job, a total lifesaver for those really long operations. And finally, that fine-grained control meant you could move just a single set of tables instead of the entire database. The game had just completely changed. But the story doesn't stop with Oracle 10G. As the whole IT landscape kept changing, with the rise of the cloud, faster networking, and way more security concerns, Data Pump had to evolve right along with it. This timeline really lays out the whole journey, doesn't it? After that revolution with Data Pump and 10G, the focus started to shift. The internet, the cloud, the constant threat of security breaches. All this meant the tool had to adapt. Versions like 12c and 19c were all about adding features for this new, super connected world. And now, with 23 AI, we're jumping into a whole new phase, one that's driven by AI and automation. And these enhancements were absolutely critical. Network mode meant you could move data directly from one database to another without needing a separate file in between. That was a huge time saver. Compression and encryption became standard features, tackling storage efficiency and security right out of the box. And, of course, as the world moved to the cloud, tight integration with cloud object storage became a must-have.
Which brings us right up to today. Data Pump has evolved from a tool you run from a command line into a core, intelligent engine. It's now a fundamental piece of Oracle's big vision for a totally autonomous, self-managing database.
So what does that actually mean? Well, it means that in Oracle 23 AI, you don't even have to tell Data Pump how to do its job anymore. It can actually analyze the system and automatically figure out the best level of parallelism to get the fastest performance. It can handle all the encryption and security automatically. The whole process is just streamlined with this new layer of built-in intelligence.
This path really shows the whole story in 4 simple steps. It started out as a simple little utility, then it was completely reborn as a high-speed engine. It adapted to become a secure tool for the cloud era, and today it's become this intelligent, autonomous part of a modern data platform. Every single step was a direct response to the changing demands of technology.
And in the end, that's what this is all about. From the days of floppy disks and tape drives all the way to today's autonomous cloud, the tool has transformed completely. But its fundamental purpose, that's always been the same. It is, and always has been, the engine that moves Oracle data across generations.